Did you know that every year, American farmers harvest over 1.5 billion tons of almonds? An enormous amount, enough to blanket the entire city of San Francisco under a 4-centimeter layer of almonds? But have you ever wondered how these tiny almonds manage to rise as a symbol of health and prosperity, generating billions of dollars annually? That journey begins in vast almond orchards, where each almond is carefully nurtured under the golden California sun. From there, they make their way into cutting-edge factories, where advanced technology transforms these humble nuts into irresistible creations, from crispy salted almonds to sweet, fragrant almond candies. Today, join Agriculture Insight as we explore some of the most modern almond processing plants and uncover the secrets behind the irresistible appeal of every fresh almond. All will be revealed in this video. Imagine yourself standing in an endless almond orchard, where rows of sturdy trees stretch under a clear blue sky. Welcome to California, the kingdom of almonds. Every year, California produces over 1.2 million tons of almonds, accounting for 80% of the world's supply. Behind the humble exterior of the almond lies a massive industry worth billions of dollars. Few people know that just over 20 almonds contain up to 160 calories, equivalent to a chicken drumstick. Despite the high calories, almonds are a miracle for dieters thanks to healthy fats that keep you full longer. However, eating too many can backfire. Eating less but right is the smart choice. But almonds are more than just nutritional value. Beneath the pure white beauty of almond blossoms, producing 1 ton of almonds requires over 10 million liters of water, while California is suffering from severe drought. Therefore, as sustainable production gains attention, each harvest marks a new beginning, where cultivation efforts, technology, and faith in a greener future come together in every ripe almond. The journey of almonds begins in January or February, when young almond trees are planted in California's Central Valley, the almond capital of the world. With its hot, dry climate and fertile soil, the region offers ideal conditions for these trees to thrive year-round. At first, the trees are planted in evenly spaced rows and paired with drip or micro-sprinkler irrigation systems, which deliver water and nutrients with precision and efficiency. Modern drip irrigation systems allow water to go directly to the roots, minimizing evaporation and waste. Meanwhile, micro-sprinklers help maintain even soil moisture and deliver fertilizers through the water, supporting healthy growth throughout the tree's life cycle. What sets almonds apart from many other crops is their deep root system and high water demand. This is largely because their growing season coincides with California's dry months, requiring consistent watering to maintain tree health and productivity. Although drip irrigation helps conserve water, the fact that almonds bear fruit annually means water consumption remains high to sustain yields throughout the production cycle. In the first 1 to 2 years, farmers focus on developing strong canopies and healthy root systems. Modern machinery is used to prune dead or overlapping branches, ensuring each tree receives ample sunlight and grows vigorously. By the 3rd or 4th year, when the trees bloom in vibrant shades of pink and white, the pollination season officially begins. At this time, over 2 million beehives are brought into almond orchards. The bees gently collect pollen from the newly blossoming flowers. With their busy wings, they transfer pollen from one blossom to another, promoting fruit development in the almond trees. For years, almond growers have partnered closely with beekeepers to ensure successful harvests, a collaboration that supports healthy trees and high yields for seasons to come. After months of care under the summer sun, by late summer to early fall, the green outer hull of the almond begins to split open, like a smile from nature, signaling that harvest time has arrived. To harvest almonds quickly, a machine called a tree shaker is used. The tree shaker is an agricultural engineering marvel, equipped with a mechanical arm and hydraulic drive system that clamps securely onto the tree trunk. When activated, it produces rapid and precise vibrations, almost like dancing with the tree, creating a joyful rain of almonds that fall evenly and efficiently. Each tree shaker can harvest 10 to 15 almond trees per hour, depending on its size and capacity. In the past, farmers had to shake trees manually using long poles, which was time-consuming and posed safety risks. The advent of the tree shaker has drastically shortened the harvest period from several weeks to just a few days, reducing labor costs and nut loss while boosting overall production efficiency. After the almond rain from the tree shaker falls to the ground, a modern device called a sweeper is used to make the harvesting process easier. The sweeper is equipped with rotating brushes that gently sweep the almonds into long, straight rows, known as windrows. These rows are neatly arranged between the tree lines, creating tidy strips of nuts, ready for collection. The machine operates smoothly, allowing for quick gathering while minimizing damage to leaves and soil. Organizing the almonds into windrows helps the harvesting equipment work more efficiently, speeds up the collection process, and protects nut quality by reducing breakage. After a few days of sun drying to reduce moisture and improve nut quality, the main harvesting phase begins. Almond sweepers move along the windrows, collecting the nuts and transferring them into specialized trucks. These machines are often equipped with advanced fans and filtering systems that help remove leaves, twigs, and dust, ensuring that only clean, intact almonds are gathered. As a result, post-harvest processes like sorting and processing become easier and more efficient. Finally, the harvester began pushing rows of almonds onto the long conveyor belt. The nuts poured into the truck bed like a small stream, layer upon layer, dusted with soil and kissed by the sun and wind, painting a vivid picture of the harvest season. In just a moment, the truck bed was piled high with mountains of almonds, ready to set off, carrying with them the breath of the earth and the hopes of the farmers for a bountiful season, beginning a new journey from orchard to table. When almonds are transported to processing facilities, they often still have their green outer hulls and hard shells, along with some debris such as dry leaves, small twigs, and soil. Before hulling begins, the almonds undergo a thorough cleaning process. First, they pass through a de-sticker machine, which removes larger branches without damaging the nuts. Next, the almonds move to the destoner, where a stream of air blows away lighter debris, while vibrations help dislodge any hardened soil clinging to the surface of the nuts. Finally, the almonds pass through a de-twigger, which completely removes any remaining small twigs and impurities. The next step is hulling. The process begins by loosening the green outer hull using a gentle rotating or friction mechanism. The loosened hulls are then removed by a vacuum or air suction system, ensuring the production line remains free of impurities. After the outer hull is removed, the almonds are transferred to a gravity table to separate any remaining debris. Nuts that still have their hard shells continue along the main processing line, where they pass through a camera-based inspection system that detects and removes any substandard almonds in preparation for the next shelling stage. The shelling process begins by feeding the almonds, still encased in their hard shells, into a specialized shelling machine. This machine uses gentle mechanical force to crack and separate the shells, while ensuring the almond kernels inside remain intact and undamaged. After shelling, the almonds are transferred onto a vibrating conveyor, equipped with sorting holes to classify them by size. Smaller kernels fall into separate bins and are typically used for almond butter or baking ingredients. Larger kernels continue down the line to meet the standards of premium markets. It is common for the upper class to leverage their financial and social power to pay a significant premium for the privilege of securing the highest quality almonds during the very process in which they are being sorted. In a high-tech environment, almonds undergo quality inspection using advanced computer software. Supercomputers operate around the clock to identify almonds that meet strict quality standards. Next, high-resolution scanning cameras detect tiny cracks or surface scratches on each almond. The system then calculates the exact coordinates and sends the data to robotic arms. These robotic arms swiftly and precisely remove the defective almonds from the processing line. Finally, human workers perform a final inspection, removing any remaining defective almonds to ensure the highest quality. The almonds are then sorted into bins of different colors based on their quality. Red bins typically hold premium-grade almonds, while green and yellow bins contain second-grade ones. This manual sorting process helps detect subtle imperfections and handle special cases, tasks that automated systems may not execute perfectly. Steam pasteurization is the most common method used in the United States, in which hot steam is applied for a short duration to eliminate harmful bacteria such as salmonella. This process is highly effective, preserving the natural flavor and texture of the almonds while meeting strict food safety standards. After pasteurization, the almonds are moved to the packaging stage. Large bins are carefully prepared and securely sealed to preserve freshness and quality during transport. These bins are then delivered to specialized processing facilities. There, the almonds continue their journey, being transformed into delicious products such as salted roasted almonds or sweet almond toffee. To make salted roasted almonds, the nuts are placed in an oven or automatic roaster and roasted at a temperature of 150 to 180 degrees for about 10 to 15 minutes to ensure they are evenly cooked and crispy. While still hot, the almonds are sprayed with or coated in a salt solution for even seasoning. Finally, the nuts are quickly cooled and sealed in airtight packaging, ready to be delivered to customers. Alongside salted roasted almonds, another irresistibly sweet treat is almond toffee, a crunchy, buttery snack that delights with every bite. The main ingredients for toffee include sugar, butter, cream, and a pinch of salt. First, the butter and sugar are melted together in a large pan over medium heat, stirring constantly to prevent burning and to create a smooth mixture. Next, heavy cream is added to enhance the texture and balance the sweetness. The mixture is then cooked to a high temperature, around 150 to 155 degrees Celsius, 300 to 311, until it reaches a soft, pliable consistency. Once the desired consistency is reached, the butter-sugar mixture is poured onto a metal surface to cool before moving on to the next stage. As the mixture cools and solidifies, it is cut into small pieces. Sharp cutting blades are typically used for this process, ensuring precise cuts so that each toffee piece is uniform in size and shape. Next, the toffee pieces are transported along a conveyor belt, where a stream of warm chocolate coats the surface evenly. This chocolate layer creates a smooth outer shell and enhances the toffee's distinctive flavor. And finally, the most important stage arrives, just as each chocolate-coated toffee piece sets into a glossy, rich finish. They are then bathed in a golden shower of roasted almond slivers. The fragrant, oil-kissed almond shards cling tightly to the still warm chocolate, forming a crisp, flavorful armor. It is this delicate harmony between the nutty, mellow almonds and the rich sweetness of the toffee that gives the candy its soul and iconic character. And so, the journey of each almond comes to a close, from sun-drenched orchards, through modern technology, to fragrant roasting ovens. Each tiny almond now wears a unique coat, ready to awaken the senses and carry the story of a land's unwavering dedication. As one of the oldest foods on the planet, mushrooms were once believed to be the food of the gods, reserved exclusively for royalty and the elite in ancient times. Out of approximately 2,000 edible mushroom species, only about 20% are cultivated on an industrial scale, with familiar varieties like shiitake, enoki, and especially white button mushrooms, which account for 40% of the global market. In the race to dominate the multi-billion-dollar mushroom industry, China leads by a wide margin, producing over 90% of the world's supply thanks to massive-scale, low-cost cultivation. Meanwhile, countries across the globe such as the United States, the Netherlands, and Poland stand out for their advanced technology, consistent quality, and strong exports of premium-grade mushrooms. With a meaty, slightly chewy texture, high plant-based protein content, low calories, and rich fiber, mushrooms are often dubbed nature's clean meat, especially popular in modern vegetarian cuisine. In the world of fine dining, mushrooms can even take on a luxurious image, as seen with the white truffle, the most expensive mushroom today, fetching prices as high as $7,000 per kilogram. Have you ever wondered where the mushrooms you eat every day, on pizza, in noodles, or in salads, actually come from? The journey of a mushroom begins with an organic feast called the substrate, a nutrient-rich mixture that serves as the mother soil for fungi. This is a crucial step that determines the yield, quality, and uniformity of the final product. No matter how advanced the technology is, a mistake at this stage can lead to the failure of the entire crop. Unlike plants, mushrooms have no roots and don't need sunlight. Instead, they grow by directly absorbing organic matter from their surroundings. Depending on the species, the substrate formula is adjusted accordingly. For example, oyster mushrooms prefer straw and soft sawdust, while shiitake mushrooms thrive on cellulose-rich wood chips. The process begins by collecting carbon and nitrogen-rich materials such as wheat straw, hardwood sawdust, ground corn cobs, aged chicken manure, used coffee grounds, or cocoa husks. The straw and other dry components are soaked in tanks or water systems to soften their structure and increase initial moisture content. Next, additives like gypsum, limestone, or rice bran are mixed in to adjust the pH, neutralize odors, and help control toxic gases during the composting process. The substrate is composted for 5 to 10 days, during which aerobic microorganisms break down organic matter, generating heat and raising the internal temperature to 50 to 70 degrees Celsius. The rising steam is a clear sign that fermentation is progressing effectively. The mixture is regularly turned to ensure uniform decomposition and to prevent anaerobic conditions. Next comes the pasteurization stage, where the mixture is treated with hot steam at 58 to 65 degrees Celsius for 6 to 8 hours. The goal is to eliminate pathogens, retain beneficial microbes, and create an ideal environment for mushroom mycelium to thrive. After composting and sterilization, the compost is shredded and loosened by a machine, then passed through a continuous conveyor system to increase aeration. The mushroom spawn, typically grain kernels inoculated with mycelium, is evenly spread over the compost using an automatic spreading system, ensuring accurate distribution and providing an ideal foundation for mycelial growth. Once mixed with spawn, the compost is packed into trays, bags, or bins, depending on the farm's setup, and placed in sealed incubation rooms arranged in tiers for space and climate efficiency. This 14 to 21 day stage is kept at 24 to 26 degrees Celsius, 95% humidity, and low light, allowing the mycelium to spread across the substrate like a white web. At this stage, a special layer called casing is added to the surface of the compost trays. This casing is typically made from peat moss, fine soil, or a mixture of crushed limestone, and sometimes mixed with sterilized clay or fine sawdust to adjust moisture retention and texture. The materials are blended using large mixing machines with spiral blades which fluff the soil, break up clumps, and ensure an ideal, airy, and uniform mixture. The casing layer doesn't provide much nutrition, but plays a crucial physiological role. It triggers changes within the mycelium system, stimulating the transition from the vegetative stage to the fruiting body formation stage. The casing layer plays a physiological role, triggering the mycelium's transition from the vegetative stage to fruit body formation. To maintain moisture, prevent erosion, and create a stable, cool environment for mycelial development, water is gently sprayed onto the casing layer using an automated irrigation system. Growers adjust the environment by lowering the temperature to 16 to 20 degrees Celsius, introducing dim light, and increasing ventilation to stimulate mushroom pinning. After 5 to 7 days, mushroom pins begin to appear and grow rapidly, often doubling in size within 24 hours, and reach harvest size within the next 3 to 5 days. This is also when skilled hands and synchronized machines take part in one of the most sensitive and crucial stages, mushroom harvesting. At large-scale industrial mushroom farms, automated harvesting machines are used to quickly collect mushrooms in large quantities. These systems are typically integrated directly into multi-tiered growing racks, where thousands of mushrooms grow evenly on substrate trays. At harvest time, mechanical sweeping arms move along each tier, pushing mature mushrooms onto a conveyor belt below. The machine can process up to 600 kilograms of mushrooms per hour, 3 to 5 times faster than manual labor, cutting labor costs by up to 70% and ensuring timely harvest before mushrooms overgrow within 24 hours. However, due to its bulk sweeping mechanism, around 5 to 10% of mushrooms may get bruised or have broken stems. And if you're the type who gets mildly OCD about imperfect mushrooms on the conveyor, don't worry, there's still a more delicate option, hand picking, where each mushroom is selected and handled like a work of art. In this method, the mushroom picker uses hands, knives, scissors, or specialized tools to gently detach the mushrooms from their substrate without crushing the stems or leaving any soil behind. The plump, white mushrooms, as soft as cotton, are carefully placed into breathable trays, with each movement resembling the careful handling of a fragile, living creature. The key factor is timing. Just a few hours of delay, and the mushroom caps can spread open, becoming soft and losing their freshness. Some mushroom varieties can double in size overnight, making the picker's task feel like waiting for the birth of a child. Always alert. Mushrooms have the ability to communicate through an underground network called mycelium, which helps them exchange nutrients and alert each other of potential threats. However, when harvesting, the picker cannot make the mushrooms sense their intrusion. Therefore, they must be extremely careful not to disturb this delicate network. An experienced worker can harvest over 1,000 mushrooms a day. They must quickly identify which mushrooms meet the standard and remove any that are moldy, cracked, or have damaged stems. Thus, each mushroom is not just a product of nature, but also part of a refined ecosystem where humans and nature harmoniously coexist. In modern mushroom farms, harvesting robots have become powerful allies, replacing humans in tasks that require precision and gentleness. Equipped with smart cameras and image processing technology, these robots can accurately identify mushrooms that meet quality standards and gently pluck them without damaging their delicate stems. Next, the mushrooms are passed through a circular blade to trim off any excess stem, ensuring a neat and uniform appearance. With the ability to operate continuously without fatigue, robots help increase productivity, reduce labor costs, and maintain consistent quality. Although they have yet to fully replicate the finesse of human hands, these steel arms are clearly paving the way for a new era, where technology and agriculture join forces to elevate the humble mushroom in the age of smart production. Meanwhile, right after being separated from the substrate, the mushrooms are quickly transferred to the primary sorting area, where the first evaluation takes place, determining the next journey for each individual mushroom. Here, Skilled workers or intelligent image scanning systems carefully inspect each mushroom based on strict criteria, from size, stem curvature, and cap color, to the surface cleanliness and overall integrity. Mushrooms that meet the standards, straight stems, evenly rounded caps free from bruises, are moved to the next processing stage. In contrast, those with cracked caps, damaged stems, or uneven shapes are sorted out for other uses, such as further processing or drying. Within a fraction of a second, the system can deliver accurate and consistent decisions, a seamless blend of machine speed and human-defined standards. Sorting may seem simple, but it is a crucial step in defining product quality, where each mushroom is treated not merely as a piece of agricultural produce, but as an individual unit, carefully selected before it reaches the consumer's hands. After being sorted, the mushrooms continue their journey on specialized ventilated trays, typically made from high-grade food-safe plastic. These trays are designed for durability and optimal airflow, helping to protect the mushrooms from bruising during internal transport, while also maintaining the right humidity and temperature to prevent wilting or dehydration before the next processing stage. An automated conveyor system moves the trays along pre-programmed routes to designated processing zones, such as washing, slicing, fresh packaging, or further processing. Thanks to this seamless system, the factory can handle several tons of mushrooms per day, with impressive accuracy and an extremely low rate of damage. This is a key factor that enables the modern mushroom industry to preserve freshness, consistency, and food safety. From farm to supermarket, from family meals to high-end dining tables. Mushrooms that meet commercial standards, uniform, intact, and visually appealing, are packed into plastic containers, then either wrapped in plastic film or vacuum sealed, depending on preservation requirements. In addition to whole mushrooms, some fresh mushroom products are sliced to suit quick preparation needs or the ready-to-eat food market. The packaged mushrooms are then labeled, marked with expiration dates, and placed in cold storage, awaiting distribution to supermarkets, restaurants, or export to international markets. Meanwhile, another portion of the mushrooms is sent to advanced processing lines to be turned into delicious, convenient canned mushrooms with a long shelf life. Across the vast vineyards of California, Washington, and Oregon, clusters of ripe, glistening grapes shimmer under the golden sunlight, signaling the start of the harvest season, typically from late summer to early fall, between August and October. Workers and harvesting machines spring into action, ready to take these fresh, juicy grapes on their journey to becoming exceptional products. When it's time for harvest, modern machinery has become an indispensable tool in large vineyards, where speed and massive workloads are essential. These grape harvesters are designed with advanced technology, allowing them to move smoothly between rows of vines without damaging the grapevine's structure. The operation of these harvesters is impressive. They use vibrating bars or gentle shaking mechanisms to create enough movement to detach each grape from the stem without harming the fruit or the vine. Once the grapes are detached, they fall into an integrated conveyor system which transports them to a large collection bin. During this process, the machines are also equipped with a preliminary sorting system that removes leaves, stems, and small debris right in the field, ensuring that the harvested grapes are of the highest quality before being transported. After the grapes are harvested by machine, they are transferred from the harvester's conveyor belt into the trailer using an automatic lifting system. The trailer is designed to be sturdy and spacious, ensuring the grapes stay fresh throughout the journey. Then, the trailer transports the grapes to the collection area, where large trucks are waiting to carry them to the processing plant. This mechanical harvesting method is perfectly suited for grapes destined for winemaking. Alongside red grapes, green grapes are also harvested in the same manner, ensuring they meet the quality standards required for producing wine. The efficiency of these modern harvesters is truly remarkable. One machine can harvest dozens of acres in just a day, significantly saving time and reducing reliance on manual labor. What's even more impressive is that these machines are programmed to operate precisely and in sync, ensuring high productivity while maintaining the quality of each grape cluster. Grape harvesters are a significant investment, with prices ranging from $75,000 to over $500,000, depending on the brand, size, and advanced features. Enjoy the vibrant sounds of grape harvest in the fields right now. After being harvested, the fresh grape clusters are transported directly to the winery, where they begin their transformation into premium wine, crafted with artistry and refined flavors. Making wine from red grapes and white grapes is exactly the same, so let's dive into the more colorful journey of red grapes. The red wine making process begins with receiving fresh grapes harvested from the vineyard. The grapes are quickly inspected to remove any impurities or unsuitable clusters before moving to the next stage. Once received, the grapes are placed on a vibrating conveyor for sorting. The vibrating mechanism helps remove impurities like leaves, small branches, or damaged grapes. On the vibrating conveyor, the grapes are separated from their stems using modern machinery. This process is designed to gently detach the stems without damaging the fruit. The stems are completely removed, leaving only the grapes to move on to the crushing stage. After being destemmed, the grapes are sent to a crusher where they are gently pressed into juice. The skins, seeds, and juice are kept together to retain the natural flavors, color, and tannins essential for red wine. This step prepares the raw materials for fermentation. The grape juice, along with the skins and seeds, is transferred to large stainless steel tanks to begin settling and fermentation. Fermentation occurs as natural or added yeast transforms the grape sugars into alcohol, creating the wine's unique flavor profile. The process is followed by malolactic fermentation, which converts malic acid into lactic acid, softening the wine and enhancing its texture. Once fermentation is complete, the wine is moved to oak barrels for aging, typically lasting 12 to 18 months. Oak barrels add complex flavors and a better structure to the wine, imparting notes of vanilla or light toast. During aging, the wine also absorbs a small amount of oxygen through the wood, softening the tannins and improving its overall quality. After the wine has aged in oak barrels, experienced inspectors play a crucial role in quality assessment using their refined tasting skills. They carefully draw samples from the barrels and evaluate the wine based on its aroma, flavor, and texture. This hands-on approach ensures that each batch meets the high standards required before moving to the bottling stage. After aging, the wine is filtered and transferred into bottles for preservation and distribution. Wine is bottled in glass. Glass wine bottles are made by melting raw materials at high temperatures, shaping them in molds, cooling them, and inspecting for quality before filling with wine. Next, the glass bottles are placed on an automated conveyor belt, where they are filled with wine using precision machinery that ensures the exact volume is poured into each bottle, maintaining consistency throughout the entire batch. Once filled, oak stoppers are gently pressed into the bottles by specialized equipment to ensure a tight and secure seal, preserving the wine's flavor and quality. After sealing, the bottles travel along the conveyor to be labeled with detailed information about the wine, such as its origin, vintage, and grape variety. Finally, they are stacked on pallets for ease of transportation, ready to delight wine enthusiasts around the world. Some premium wines are sealed with oak stoppers to enhance their elegance and provide a natural, high-quality finish that aligns with the wine's luxurious image. The oak stopper not only adds a touch of sophistication, but also contributes to preserving the wine's flavor and ensuring a tight seal for long-term storage. Alongside modern winemaking techniques, traditional methods still hold their charm. One such method involves crushing grapes by foot in large open vats, where the juice, skins, and seeds are gently mixed to extract flavors, color, and tannins. This hands-on approach prevents the seeds from breaking and adding bitterness, preserving the wine's natural balance. After crushing, the must undergoes fermentation, where natural or added yeasts transform the sugars into alcohol, creating the rich complexity of traditional wine. After that, they are also transferred to oak barrels for aging, just like in the standard modern production process. This process, though time-consuming, is cherished for its connection to history, culture, and the art of winemaking. In addition to winemaking, grape juice production focuses on preserving the fresh, natural sweetness of the grapes without fermentation. After harvesting, the grapes are carefully sorted, washed, and crushed to extract the pure juice. Unlike winemaking, the juice is immediately pasteurized to prevent fermentation, ensuring it remains non-alcoholic while retaining its vibrant flavor and nutritional value. The grape juice is then filtered to remove any impurities, creating a clear and smooth product. Afterward, it's bottled, sealed, and often treated to maintain its freshness during storage and transportation. Next, we come to the process of making raisins. Typically, raisins are made from green grapes because these grapes are seedless and have a high sugar content and thin skin, making them ideal for drying. Once the grapes reach full ripeness, they are left on the vine to dry naturally under the sun. Over a few weeks, the moisture in the grapes evaporates, concentrating the sugars and creating the unique flavor of raisins. This process requires close monitoring to prevent mold or spoilage. When the grapes are sufficiently dried, specialized harvesting machines are used to collect them. These machines gently shake the vines, causing the dried grapes to fall onto soft collection trays below, minimizing damage. The raisins are laid out in carefully prepared rows on the ground to dry completely under the sun. Once the raisins have reached their perfect level of dryness, another machine gently lifts them from the ground into containers, preparing them for transport to the processing plant. At the factory, the raisins first pass through a vibrating system that helps loosen and remove debris like stems, leaves, or dirt clinging to the surface. From there, they move to a water-based cleaning system, where they are thoroughly washed to ensure they meet strict hygiene and quality standards before further processing. Next, the raisins are passed through a drying system to remove all moisture. Next, they are sorted automatically by size, color, and quality. Raisins that don't meet quality standards are removed or used for other purposes, such as livestock feed. After that, they move to the manual sorting stage. Workers stand along both sides of a moving conveyor belt, carefully inspecting the raisins as they pass by. Finally, the raisins are packed into vacuum-sealed bags or airtight containers to retain their freshness and natural flavor. The packaging is labeled with information about the origin, nutritional facts, and expiration date. The finished product is then distributed to stores and consumers worldwide. Chickpeas are typically grown in areas with dry climates, loose, nutrient-rich soil, and warm weather. These little legumes thrive in conditions with moderate rainfall and low humidity, which help reduce the risk of pests and promote high yields. Chickpeas are not just an excellent source of plant-based protein, but they are also packed with fiber, iron, and essential minerals, making them a highly nutritious addition to meals. In the US, chickpeas play a significant role in both agriculture and the food industry. Additionally, they bring environmental benefits thanks to their nitrogen-fixing ability, which improves soil quality and reduces the need for chemical fertilizers. This makes chickpeas a top choice for sustainable farming systems. When harvest season arrives, the sprawling fields of chickpeas transform into a vibrant and bustling scene. It's not just a time for American farmers to reap the rewards of months of hard work, but also an opportunity to leverage modern technology to maximize efficiency and productivity in the harvesting process. Recognizing the right time to harvest is absolutely crucial. If harvested too early, chickpeas will retain too much moisture, making them prone to spoilage during storage. On the other hand, waiting too long can cause the seeds to become overly dry and hard, reducing their commercial value. Harvesting chickpeas in the US relies almost entirely on modern machinery, particularly combine harvesters. These machines are designed to handle multiple tasks at once, including cutting the plants, collecting the beans, and removing the unnecessary parts like stems, leaves, and pods. They are built to operate efficiently on large fields, even those with slightly sloped terrain. During a harvest day, the combine harvester moves steadily and methodically down each row. The cutting blades at the front gently trim the plants, feeding them into the machine's internal system. Inside, the chickpea beans are separated from the stems and pods, then collected in a large onboard container. The leftover plant material, such as leaves and pods, is returned to the field as natural fertilizer. This process not only minimizes waste, but also enhances soil quality for the next planting season. Using modern machinery not only saves farmers time, but also significantly boosts productivity. A single combine harvester can cover dozens of hectares of chickpeas in a day, a task that would be nearly impossible for hundreds of manual laborers to accomplish. Additionally, these machines are equipped with advanced sensors that help farmers ensure precise seed separation and minimize losses during the harvesting process. In the food industry, the color and shape of chickpeas are crucial factors that determine their commercial value. Thanks to modern machinery, farmers can ensure that the beans remain intact and free from damage, maintaining their smooth beige color and uniform size, qualities that are highly desirable for producing products like hummus or chickpea flour. chickpea harvesting process in the US is a clear example of how modern technology is being fully integrated into agriculture. Combine harvesters not only enhance production efficiency, but also reduce the physical burden on farmers, allowing them to focus more on improving crop quality. As a result, the U.S. has established itself as one of the leading producers of chickpeas globally, playing a key role in meeting the growing demand for sustainable and nutrient-rich foods. The journey of harvesting chickpeas goes beyond simply transporting beans from the field to storage. It reflects the creativity and dedication of American farmers in connecting the land, technology, and communities. With continuous advancements in technology and farming practices, the chickpea industry will remain a shining example of high-tech agriculture in the United States. After harvest, chickpeas are transported to processing facilities where they are cleaned and sorted. Modern machinery removes impurities like branches, leaves, and small stones. The chickpeas are then dried to reduce moisture levels, ensuring the quality of the beans during storage and processing. Beans that meet quality standards are packed into tin cans filled with brine or natural soaking water, allowing for long-term preservation and maintaining their flavor. In addition to canned chickpeas, they are also processed into hummus, chickpea flour, or pasta, and packaged in plastic containers or sealed paper bags. Chickpeas that do not meet quality standards are repurposed as livestock feed, ensuring resources are used efficiently and contributing to a sustainable supply chain. This process supports both domestic consumption and export demands effectively. Harvesting chickpeas is impressive, but have you ever wondered how American farmers plant this highly nutritious crop? Let's dive into this fascinating journey right now. Chickpeas are planted on vast fields, covering hundreds or even thousands of acres. The entire planting process is carried out using modern machinery, which boosts production efficiency, optimizes yields, and minimizes reliance on manual labor. Chickpea seeds are sown using automatic seed planters. These machines are programmed to plant the seeds at the ideal depth, typically 1 to 2 inches below the surface, and with a spacing of about 6 to 8 inches between each seed. This setup ensures that the chickpea plants have enough space to develop strong roots and receive ample sunlight for healthy growth. During the growth phase, chickpea fields in the U.S. are closely monitored using advanced technology. Modern irrigation systems such as drip or sprinkler irrigation deliver water precisely and efficiently, ensuring that chickpea plants, already drought-tolerant, grow robustly. By applying cutting-edge technology, chickpea farming in the U.S. achieves high yields and superior quality, meeting the growing demand in global markets. This approach is a clear example of sustainability in modern agriculture. Chickpeas are a highly nutritious food, especially known for their high plant-based protein content, making them a great choice for both vegetarians and non-vegetarians. These legumes are rich in fiber, which supports a healthy digestive system and helps regulate blood sugar levels. Chickpeas are also packed with iron, potassium, and magnesium, which contribute to better heart health, stronger bones, and a well-functioning nervous system. Additionally, vitamin B6 in chickpeas plays a key role in energy metabolism and brain function. With their abundant nutritional benefits, chickpeas are an ideal choice for a healthy and balanced diet. And there you have it, a complete look at how American farmers harvest millions of pounds of chickpeas. Thank you for joining me on this fascinating journey. If you have any questions or thoughts, feel free to leave a comment below. Don't forget to hit the like button and subscribe to the channel to explore more amazing stories from the world of agriculture. Goodbye for now, and see you in the next video.